Hi, and thanks for joining me in this video about IFR conditions. We're going to look at the different causes of IFR conditions in this video. Discussion by looking at things that cause low visibility.
Okay, we're working our way through low visibility and we're going to look at different kinds of fogs right now.
In this video, we'll classify the different types of fogs and the methods for formation.
So we'll start out our fog types with radiation fog. This is probably the one that's most obvious or most familiar to you. It's one where the ground cools, and as a result the air touching the ground also cools and reaches the dew point. So in this case, the temperature comes down to reach the dew point. You're cooling the air to saturation. During the day, the sun's out, it's warming up the ground. At night, the sun disappears, the ground gives up terrestrial radiation. That loss of energy results in a drop in temperature of the surface, and the air contacting the surface cools. So what you need are clear skies and light winds. Notice I didn't say calm winds, but light winds. Because if you have no wind at all, dead calm wind, then you'll get either dew or frost at the surface. What the wind does is it mixes up the lowest layer of the atmosphere so that you get saturation through a deeper layer. And if you had really strong winds, then instead you would get stratus or stratocumulus clouds because it dries out the lowest layer and then saturates the higher layer. So the characteristics of radiation fog typically forms late evening, early morning hours. Tends to be rather shallow, not very thick, meaning that perhaps maybe anywhere from 6 to 50 feet thick, maybe a little bit more. And then it tends to be localized, meaning that you'll see it in some areas and not in others. And then as the day progresses, it tends to burn off. The sun heating the ground will get rid of the radiation fog. Advection fog is another kind of fog that forms, but this one is a result of air moving over a colder surface and reaching saturation that way. So in this case, the temperature goes down to reach the dew point. So it does help if you have a warm body of water to produce water vapor or to give water vapor to an air mass, but that's not always the case. Regardless, an air mass with some water vapor content will move over a colder surface. That colder surface could be land or water. It may move over a cold body of water producing advection fog or cold land mass producing advection fog. So you need some movement of air. That's what advection means, the movement of air. So the required conditions are typically a source of moisture. Sometimes that's a great distance. Also you need light to moderate winds and then also a colder surface. And advection fog tends to be actually rather thick. It can happen during the day at night. It tends to cover a very large area and doesn't burn off very quickly. And you can see it set up pretty fast. It'll form rapidly and tends to be pretty dense, meaning that the visibility usually is really, really low. And this can extend to higher altitudes, might even merge with the clouds above it. Strong winds, if you have strong winds, then instead of getting advection type fog, you'll get stratus or stratocumulus clouds. How strong? We're talking winds that are probably greater than 15 to 20 knots. Usually with advection fog, you see winds of somewhere between 10 to 17 knots or so. Upslope fog is another kind of fog that results from air going up over terrain, rising terrain. And in this case, like the previous cases, the temperature drops down to meet the dew point, so you have cooling of the air. And upslope fog results from adiabatic cooling. As air rises, it expands and it cools through forced descent. So the required conditions, you need some sort of sloping terrain. It can be mountains, but also it could be a gradual slope depending upon how close the air is to saturation. You need some wind component that is perpendicular to the gradient, or in other words, it's flowing uphill. The air needs to be stable. If it's unstable, then you start getting more cumulus type elements, and you need enough moisture to reach saturation. This fog tends to be thick and dense and persistent. As long as the wind keeps flowing up the slope, it'll be there. It'll merge into clouds above it perhaps, and also the visibility is pretty poor, and then the fog will remain there as long as the wind is flowing uphill. Steam fog is another kind of fog that forms when water vapor is added to the air. So this is a little bit different than the previous ones where we're adding moisture to a cold air mass. So in this case, you're adding moisture to reach saturation, meaning that the dew point will go up. So what happens is typically over a warm body of water, you'll have evaporation. If the air is much colder than the surroundings, then as the water vapor enters the cold air mass, it almost instantaneously condenses and produces a fog over the warm water. So you need a warm, moist surface. Typically this happens over a body of water. I've seen it also happen over a parking lot after a thunderstorm, where the warm parking lot will heat the water and it evaporates into colder air. So the characteristics depend upon the source of moisture. Is it a large body of water, or is it a smaller region? So that determines the characteristics, whether it's patchy or widespread, thick or thin, temporary or persistent. Precipitation fog is another kind of fog that forms, and it forms when air falls, or when precipitation falls into cooler air. And the way that this fog forms is by evaporation, so the dew point goes up to meet the temperature. And what happens is precipitation falls into colder air. As that precipitation falls, it evaporates, and that evaporation increases the water vapor content of the air. As the water vapor content increases, it'll finally reach saturation and produce a lower layer of fog. So the air can reach saturation and reduce visibility significantly in that area of precipitation. So what you need is precipitation and unsaturated air to start with. And the characteristics of precipitation fog depends upon the source of precipitation. Is over a widespread area like a front? If that's the case, then it tends to be thicker and persistent and widespread. If it's just a thunderstorm that's passing through, then the fog tends to be rather patchy and thin and only temporary. The last type of fog we'll talk about is ice fog, and ice fog is made of ice crystals. Now, ice fog can form either way, either cooling the air to saturation or adding moisture to the air to increase the dew point. And the conditions that you need clear skies, of course, calm winds, typically really light winds or hardly any winds at all, and also very cold temperatures. We're talking temperatures that are colder than -30, and also any kind of moisture in the atmosphere. You're talking very low dew points, and that means that there's not much moisture in the atmosphere. These pictures are taken Grand Forks when the temperature dropped to -32, and you can see ice fog in the area. Now, when temperatures are really cold, when they're below -30, you're going to have ice crystals. If it's down to -34, the ice fog is not going to be persistent, means that it disappears pretty quickly. But when you get to temperatures -40 or colder, that's when the ice fog sticks around and doesn't burn off as easily. Required conditions: you need some sort of moisture source. Talking with friends who forecast in Alaska, they said a herd of caribou just breathing can add enough moisture to produce fog, ice fog over a region. I've even seen an airplane take off and shut down the airport because of the combustion from its engines releasing water vapor, and and increasing the content of the air to the point where you have ice fog. Its rare temperatures warmer than -30, and its frequency increases with colder temperatures. Those are all the different types of fogs. Next, we'll talk about other things that can obscure your vision.